Welcome back to the Hyperbolic Coding Chamber. We're back once again. Do more coding. I was just about to click start. I just clicked start. Well, right before I clicked start, I was gonna play our usual anime future bass mix music background stuff. Anyways, a ad starts playing for Hero Wars, and moral of the story is we got to keep our brains in our hands because there's a war. There's a war for our cerebellums. Okay, they're trying to get to the bottom of our brain stems, and we might be losing the war. I was watching this Hero Wars ad, and it's like, why does the knight always lose? And they scroll into the video, and there's like a 666 in the corner, and then they take the 666 and they search it on YouTube, on Google Images, and all the images are filtered out, probably all AI generated. The problem with this ad though is that it's actually a banger ad. I'm sitting here watching for like 60 seconds. These people have figured out. I'm sure they have an actual human. I'm gonna say the Hero Wars lab has an actual human strapped into a chair like this, and they have a couple of pincer needles in their cerebellum, and they're measuring in the frontal lobes and all these different sections. They're measuring the response to these ads, because these ads, they figured it out. Okay, I can't imagine even I was gonna say even a monkey would watch this ad. Maybe we're all just some hairless monkeys, man. And maybe that's what they have. Maybe they have a monkey in a chair. But either way, those people are onto something. So we got to make sure to keep our brains in our hands. Otherwise, we'll just get stuck, zonked out, and become Wall-E people. But maybe they're onto something, and maybe the Wall-E people had something figured out. So that's another question, probably for a great thinker. But maybe the Wall-E people were onto something. That being the case, we do have some questions available. So let's take a look. We have Thomas Wong Coding, legendary part-time author, visionary speaker, tennis player, as well as algorist. Says, I have a friend who started with LC1 and got stuck on IC4 median of 2 sorted array forever and gave up. I'm not sure which IC4 is, but I think I know this question, and it's true. It is true. Yeah, there's something about maybe it's just how we see ourselves or something, but it's like whenever you're about to do something and someone's like, oh yeah, this is super easy, and they're explaining to you how it's so easy and you just have to do it, and then you're like, oh man, if it's so easy, what if I do it and I can't do it? What if it's so easy and I can't do it, then something's wrong with me? And I think that happens with LeetCode when the problem is marked as easy. It's like, oh, anyone could do this, and I can't do it. So I must be worse than everyone. But yeah, LeetCode, maybe everything's like that. But I feel like we just got to take our time. This is in response to a question about what data structure and algorithms learn first. And I guess I'm going to steal Colin Galen's words on this. There's no specific path. And you can do topic. I think it's like it ranges. Some people have done topic-wise preparement. Some people have just kind of gone through, and then when they get stuck on something, they learn some more. Other people have just intuited the natural forms of the algorithms. And I feel like the solution is just not to get caught up in the perfectionism loop of trying to do everything in the perfect order in hopes that it might, the outcome might change. And maybe we can abuse perfectionism and lower the bar, right? That's kind of what we try to do. I used to have a goal to solve a problem every day when I first started. This was impossible. So what I opted for instead was I'm going to spend 10 minutes on a problem every day. And then eventually, here we are. We're still dog water, but we're less dog water than we were when we started. So maybe we're onto something. Hopefully we could keep making progress, but too true facts indeed. Spit, broski. Yeah, man, it's just so true. It's so true. What do they say? Oh yeah, I think they have a phrase for this. Something like, sometimes you play the cards I think the phrase is like, play the cards you have, not the cards you wish you had. So if you can start, if you can't do an easy, right, just, YOLO it out, make like a timer or something. Or I'm sure there's tons of different ways to make it simpler or just palatable, and everyone's different. So I'm sure there's a way that we can all find to make it Simple. And this is not in response to Thomas, but in response to the comment yesterday. I try to choose the path that keeps me leet coding. So hopefully we're not delusional, and hopefully by day 500 we're still not doing easies. Hopefully we're cooking by then, but who knows? It could be that when we reach the medians, once we reach the mediums, we're in trouble. But I think we've already learned so many small patterns from these easy problems, but I really got to get that LeetCode extension made because we're cutting corners and we're not thinking. And I think it would be a really good idea to start not looking at the test cases and trying to have to manually search through the problem ourselves, which would give us a better understanding of the problem. So it's kind of like if you had to, this makes no sense, but if you had to fix a car or a computer without being able to open it up, and this, you would never have to do this, but I feel like it would really train your visualization skills, right? If all you can do is work with the input, right, and you can't see the internal workings, I feel like you'd become a master of troubleshooting and diagnosing, right? Because it's like the car is not starting, right? And so you're going through your mind in the head, and you're going through the car in your head. I don't know much about cars, but you put the key into the plumbus, it turns the bleem flark, and something happens in the engine, and something, and then you could follow it through, and it would make a ton of sense. So I'm hoping we can do that with LeetCode, but we have to make this LeetCode extension. Or maybe, yeah, I don't think anyone's made it, but this all comes back to the goal of trying to mimic USACO, and this segues perfectly into the legendary Control-C Ninja Anbu Ops. His friend was crushed by a boulder, who later came back at the end to give his life to save the main character. Also part-time algorist, visionary, author, and general motivational speaker, petitioned to start a USACO everyday series. We would get fried. Okay, the USACO dudes are different. Okay, if you're doing USACO, you are different. You're a different human. So I don't think we could. Maybe we'll do USACO after LeetCode. But the LeetCode extension is our best bet at mimicking USAC. Is our best bet at mimicking USAC, because I don't think you get any of the test cases that are failing, and that's how we become beastly. Because now you have no choice. To make progress, we literally have to think. And that's going to be the goal. Maybe we'll drop the extension, and then the LeetCode CEO will reach out to us, and they'll make it a feature on LeetCode, and then boom. That'd be perfect. So that would be ideal. But I have a VC with the LeetCode CEO later on today, and we're probably going to talk about it. Me, Thomas, Control-C, probably a couple people in Discord. Elon, I texted Elon. He said he might hop on. He might hop on just to just to throw some jokes. But that's what we're going to be up to later. So if you're interested in something like that, you should definitely join the Hyperbolic Coding Chamber Discord. That being said, we're going to try 45 minutes. If we get beat before then, we're just gonna cut it, right, and jump into it. So where were we? Oh yeah, we were working on a problem that we stopped trying on. I stopped thinking on. Hopefully we can make it make sense. So I'm gonna start the timer. An n-by-n matrix is valid if every row in every column contains all the integers from 1 to n inclusive. 1 to n inclusive. Let's see if our Gauss formula makes sense. If we wanted to get the summation from 0 to n inclusive, we'd have n, which is 10 times 10 plus 1, which would give you 11, 10 times 11 gives you 110. Divided by 2 will give you 55, and that's definitely not how that works. If you were to sum 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, you would get, this would give you 6, plus 4 would give you 10, plus 5 would give you 15, plus 6 would give you 21, plus 7 would give you 28, plus 8 would give you 36, plus 9 would give you 45. Oh, you do get 55. Oh, okay. I actually thought that was nonsense. Somehow our answer is failing. We output true, but the expected answer was false. I see. This makes sense. I think I see how a test case like this could be failing. If we had a certain combination of numbers such that the sum was equal to the Gaussian complete formula, then we could still get the wrong answer even though the numbers sum up to the same values. Those are actually pretty good test cases. That being the case, I think we have to do the set version. Is there a way we can reuse this Gauss thing? Nah, I don't think so. The fact that you can have another number that can be added to it and you would still get the correct sum for the column kind of breaks the whole thing. That shouldn't be... So n, the smallest number in the column can be 1. Right, so for a sufficiently large enough number, it definitely does seem possible to break this whole thing up. So we can keep the 2, we can remove the Gauss stuff. And what we'll do is we'll have a set. To matrix.length, what we're going to do is load this base set with this number here. And then for each row, we're going to create a new set from the base set, right? And as we check this row, we're going to say we can remove some. We'll say if temp set does not have matrix sub row sub call, going to return false. Else, if it does, we're going to say temp set dot delete matrix sub row. And we can even make it simpler. We can say if temp set dot has it, right? Then we'll just do the line of code we're gonna do here, right? We can simplify this whole thing actually. All right, we'll delete it from the matrix. At the end, we'll say if temp dot set dot size is not equal 0, we'll return false. You can pretty much copy this, but down here, then we'll need a const temp set, which we create from the base set. Nice. Right, so the Gaussian one was clever, but at the same time, not as flames. So, yeah, maybe we should learn to cut our losses. But also, if we had thought through the examples deep enough, we would have realized there was a number that you could have created, a set of numbers that you could sum up that would not be the same as the Gaussian formula. If I'm curious, no way. So given a 2D integer array nums, where given a 2D integer array nums, where num sub I is a non-empty array of distinct positive integers, return the list of integers that are present in each array of num sorted in ascending order. Given a 2D integer array nums, where num sub I is a non-empty array of distinct positive integers, return the list of integers that are present in each of So we have to return the numbers that are present in all of the subarrays that are also sorted in ascending order. Each array is distinct, has distinct numbers. So all the arrays share the set of numbers 3, 4, 5, and 6. Wait, no, they all share 3 and 4. Return list of integers that are present in each array of nums sorted in ascending order. Wait, is it? I think I might be confusing the question. Is it asking that we should just take the number, we should just take the union of all the arrays and return all the numbers that are the same, or all the numbers that are the same in all of the arrays and sorted in ascending order? I guess it's unclear by the example, so we'll just try the first one. So we'll just throw them all into a set. Actually, a set wouldn't work. We'll throw them all into a map. And the fact that they're all distinct would make this work, because we're going to think about putting them into a map where the key is a number and the value is the number of occurrences of that number, and such each array in the matrix has a distinct array of positive integers. If we have 3 3s, it's safe to say that we have if you have three threes and we have 3 rows, it's safe to say the number 3 exists in all 3 subarrays, in all 3 arrays. Hopefully. Sub call equals an array, and we can return that array at the end. And then additionally, we could iterate through the map. Now we need to know how many numbers share the same number of occurrences, right, as the number of rows in the array. And we actually can use key and awk of map. And we'll say if awk equals nums.length, we'll do ands.push key. And then we do have to sort ands in ascending order. So if Yahoo is still a thing. Given a positive integer, check whether it has alternating bits. Namely, if 2 adjacent bits will always have different values. N equals 7. I'm sure there's a pattern here, but we could just check. I think we could do constant time, check alternating bits. But maybe there's another version where you can just know. It'd be interesting to see. 5 is 1, 0, 1. Now what is 0, 1? Actually, if there's 32 bits, you could just write 12 if statements, but this would be 1, 2, 4, 5, 8, 16, 16 plus 4 gives you 20, 21. So far we have 5, 21, 16, 32, 64. If we add 64 to this, we would get, it's like 21 plus 64 is 80, 85 plus 5 would be 90. I think it's still constant time either way. So we could check alternating bits. If we just let the starting bit equal n and 1, right? We mask it with 1. If it's 1, right, then we'll know that the starting bit is 1. If it's not, we'll know that the starting bit is 0. Then we'll say, if we get to the end, we'll return true. Afterwards, but we'll say, does not equal 0. While n does not equal 0. Okay, this is the last bit. So this to the opposite, and we'll say while n we want to slide the bits off from the end of the want to slide the bits off of an integer from the right hand side, which we can bit shift right. If we bit shift right, we have the last bit in hand. Oh no, we can just check with the current bit and then we'll bit shift. So we'll say if n and 1, right, which is the last bit at the end, if we mask it right, this would give us 0 or 1. If it equals the last bit, will return false. Otherwise, we can then just bit shift it 1. Or what's the problem with equals last bit? And then additionally, not and 1. Should be the same either way. But I think our angle is just incorrect. If we started with something like 5, which is 1, 1, 0, 1, right? We're gonna say that the last bit, which is non-existent, right, We're going to say n and 1. It does equal 1. We're going to say it's 0 because we're going to not it. Right? While n does not equal 0, which it doesn't, if n and 1, which is 1, equals last bit, which is 0, return false. It doesn't, so you bit shift it 1. Oh, we're not even updating the last bit. Oh. Last bit equals n and 1. Nice. Remove digit from number to maximize result. Remove digit from number to maximize result. You are given a string number representing a positive integer and a character digit. You are given a string number. You are given a string number representing a positive integer and a character digit. Given a string number representing a positive integer, given a string number. Return the resulting string after removing exactly one occurrence of digit from number, such that the value of the resulting string in decimal form is maximized. To number as a string, we remove a digit 3, so that the value of the resulting string in decimal form is maximized. What if you end up with 12. If you remove 1, you could get 23 though. Oh, but you have to remove 3. It feels like the best way to do it would just be to remove it from iterate from the end and remove it from the end. Back to forward. So we have 1, remove. Oh, it's not that simple. If you remove 1 from the end here, you'd get 2, 3, 1. You get 1, 2, 3, and if you remove 1 from the front, you actually get 1, 2, 3. Well, I think there's 3 cases. Digit in front, digit at end, digit in center. How do we choose digit? Somewhere in center. Maybe the question, how do we choose best digit? But I think my brain is fried for some reason, and I think we're gonna stop there.